So yeah, Entrain was one of the first round of feasibility projects. So it's actually finished in June this year. And it's called Entrain Engineering Transformation for the Integration of Sensor Networks. One of these feasibility studies between CEH and the University of Lincoln, working on sort of machine learning aspects. And we focused on these three specific networks. So CEH's Cosmos UK network, soil moisture network of around 50 sites, generating real-time data. We've got a greenhouse gas network from Flux Towers, and the Thames Initiative's water quality network. So we're kind of interested in across the sort of terrestrial and freshwater environment, integrating sensor networks. So I'll just run through some of the outputs that we focused on, produced. So a key part of it was how to integrate data from these networks. So there's loads of sensor networks out there. Even a traditional sort of Met Office data is still very hard to access. So how could we integrate data across networks to kind of have a network of networks that could be machine readable and drive decision support tools? We undertook a kind of review of database technologies for sensor data. There's an output there looking at different databases for high resolution data, particularly this kind of sub-second greenhouse gas network data, as well as other types, if these high resolution data streams are coming on. We developed a new linked data standard for some of the CEH monitoring data. So it's based on existing sensor data standards in a way that could be integrated with data, for example, from some of the EA APIs. And we also looked at how we could link monitoring data across the freshwater environment by linking them to spatial river networks and having rapid analysis from that. So there's an EGU talk on that. Another aspect of the project was actually enhancing some of these sensor networks to deliver new measurements from some of the data. So they're either kind of proxy measurements or they're kind of derived elements. So the first one is from all of these Cosmos sites have got these phenocams on that send back 4 pictures per day. And from those, we take these RGB signals. And I think they're actually probably the same data that's going to be used in the Retina project, because we've got Cosmos sensors at both those sites that were mentioned. So we've now got a real-time greenness phenology network for all of these 50 sites, which is really fantastic. We've also derived from the Cosmos soil moisture measurement a new snow depth way of measuring snow depth from that data. So when there's snow lying on top of the soils, and that comes out now in real time on the Cosmos website. We've also, from the greenhouse gas network, where the sites are co-located with the Cosmos data, we've got a daily actual evaporation or half-hourly actual evaporation data from that Flux network. And again, that's being processed in real time and coming into the network. And in terms of the water quality network, we looked at kind of linking water quality and flow sites kind of dynamically across the river network in order to do kind of dynamic load apportionment modeling. Third aspect was, and a really key aspect involving Lincoln, was machine learning for sensor quality control and quality assurance. There's a paper there that was about using machine learning to infill rainfall data at Cosmos sites. And we've since taken that work further, using it to kind of build an ensemble of machine learning models at a site, and using that as a way to understand whether the sensor data that's streaming in is likely to be good or not so good. So basically how well it matches up with our ensemble of model predictions. So to use that as a way of flagging data to both to save time and to improve the quality of data. And I think that's something that's really got a lot of potential applications across environmental science. We're implementing that now in our Cosmos network. Another aspect is on the stakeholder engagement side of things. We had a workshop on machine learning or AI for water quality analysis with a range of stakeholders. And from those, we've generated some ideas with the Environment Agency. They're very keen to take forward this idea of linking sensors across the freshwater environment in their new national ecosystem assessment approach. So some of those, there's areas in there that I hope interested to the digital environment network program. And I go to the main kind of fundamental question is, kind of comes out from it for me, is how we go ahead and build this kind of integrated network of machine actionable sensor data for the UK environment.